So you need to look at chapter 5 and 6.1 and 6.2, right? So problem number 1. List all the ways you can select two members from the set O, P, Q, and R. If the order you select the members is not important, remember, recall. So we had on the counting principles two set of formulas, NPR and NCR, right? So we use NCR formula if order is not important. Then we use the number of ways you could make arrangement from n given object, choose an R at a time. When order is important, then you have to use NPR formula, right? So these are basically coming from chapter 5. So here, list all the ways you could choose, two members from the given 4-member set. They tell what? Order is not important. What does mean by that? That means we don't count OR, RO, we count instead OR and RO as only one because we don't care about the order. So how many ways this could happen? You are given 4 in total, but we are choosing 2 at a time. Therefore, the number of ways you could make is 4 choose 2. What is 4 choose 2? Go to your calculator. 4 choose 2. So 4 choose 2 is 6. That means what? That means we could make this arrangement in 6 ways, but they are asking us to list all the 6 ways. So what are those ways? First, I could choose O and P, or you could choose O and Q, or you could choose O and R, right? Or you could choose P and Q, or P and R, or you could choose simply Q and R, right? So 1, 2, 3, 4, 5, 6. There are 6 ways. So you have to list like that. You have to write all the things. Okay. So number 2, the special GI consists of drinks, appetizer, entry, and dessert. So 1, 2, 3. There are 4 varieties of things here given. So I need to choose one at a time, right? There are 5 drinks and 8 appetizers and 12 entries and 4 desserts. How many different ways you could make? Remember, I need to make now 4 tasks. You have to choose 4 things. Task number 1, task number 2, 3, and 4. Okay. So choosing a drink, how many ways I could choose? There are 5 of them, so there are 5 ways. And entries, how many entries? Oh, then appetizers I have 8, then 12 entries, and 4 desserts. So you need to multiply them out, right, to find the total number of ways. So simply just multiply these all 4 numbers and find the answer. So if you multiply all 4, see what you'll get. So you should get 19, 20 ways, right? Okay. Right. So the next one. The equestrian club has 12 members. If the club wants to select one president, vice president, chair club, and the secretary, so they have to choose four. Remember, for the title, order is important. Therefore, you need to use NPR formula. So you are given title, right? So rank is there. So you are given 12, but now I need to use the permutation formula. You have to choose 1, 2, 3, 4, right? So that is 12, 3, 4. So what is that? 12, 3, 4, which is 1188. Okay. Right. Number 4. The research director at NASA must choose 5 experiments for the next space shuttle. If 8 experiments are proposed, in how many ways can this decision be made if the order is important? So order matter. Therefore, you have to use NPR formula. So we need to choose 5 from 8, right? Therefore, 8P5. What is 8P5? 8P5. That is 6720 ways. Okay. The next one, again, counting principles. So we need to look at the counting numbers we learned in chapter 5. Automobile license plates consist of 4 letters followed by 2 digits. Therefore, you have to alert the slots, right? 4 letters followed by 2 digits. How many different possible license plates are possible? If letters and numbers may repeat, okay, repetition is allowed, right? So you need to choose first the 4 letters, then 2 numbers. So there are 26 ways you could choose letters, but numbers are repeated, so all 26 will be here. Then letters, you see this is so for numbers 0 to 9, there are 10 of them, but repetition is allowed, therefore 10, 10. So simply just multiply this all. And this answer. So you need to multiply 26 times 26 times 26 times 26 times 10 times 10, which is 100. So you have this much base, right? 45, 697. Okay. Right. Number 6. How many ways can a 4-card poker hand consist of all face cards? So you are choosing 4 at a time. All 4 supposed to be from face cards. So how many ways you could make this happen? How many face cards there in total? Go ahead and check your sample space. So now face cards. There are, okay, so before going to start, let's look at these two. These two are supposed to be so these two supposed to be black, right? So these two are red. So this is clubs. This is spades, and this is hearts. And the last one is diamond, right? So first two are black. Okay, now I need face card, right? So each variety has a three face card. So in total, you will have this much face cards, right? This is all my face card. So how many are there? There are 12 of them. So among those 12 now, I need to have four, four face, right? Therefore, the number of ways this could happen is 12, choose 4. Order doesn't matter, right? So order is not important here.
495.
495.
Yes.
Okay, I believe in you. 495. There are 12 face cards. Okay. Number 7. Describe each event as a set of outcomes. So you need to describe the event in set notation, right? So you need to write the answer in this format. So I introduce letter E as my event. So you have to write the outcomes inside the set notation, right? When 4 coins are flipped, we obtain exactly two tails. Remember, so my sample space for this problem, let's see who is telling how many outcomes I have in my sample space. One of you can give me the answer. Yes? Hi there. Anyone? How many outcomes I have in my sample space? Collection of all possible outcomes. You are flipping 4 coins. You need to have a 4 tasks now, right? Each coin has 2 outcomes, either heads or tails. Therefore, each has 2 outcomes. In total, I have 2 times 2 times 2 times 4, 2 times 2, which is 16. Therefore, 16 outcomes there in my, um, my sample space, right? One of these 16 is like we have all heads, all 4 coins giving heads, or you may have heads in the last one tail and so on, and you will have maybe tails all 4. So these are the possible outcomes. So if you count, you should have 16 of them. Among those 16, now what is my event? My event is here. This is your event E. That is, you have to have exactly 2 tails. Among these all possible outcomes, we have to have 2 T's and 2 H, right? Okay, what are those? It means my event E may have heads, heads, tails, tails, or heads, tails, tails, heads, or tails, tails, heads, and I may have a heads, tail, right? Or we may have a heads. How many possible outcomes for this particular event I have? Remember, we are tossing 4 coins. Among 4 outcomes, I'm looking for now 2 tails. Therefore, my task is 4C2. 4C2 ways. 4C2 should be 6. That means you should have 6 outcomes inside. 1, 2, 3, 4, 5. One is missing. Could you guess which one I missed? Yes?
Tails, heads, tails.
Tails, heads, heads, tails. Very good. It is missing. So these are the possible outcomes we have for this particular event E. Remember, my event E here, event E is always the subset of your, the sample space, right? Yes. Sample space has all the collections. From here only we are choosing from my event E, right? So here there are 16 of them. I need only 6 from these all 16 outcomes. So I am choosing whatever, 2T's, those outcomes are collection of outcomes I have here for my particular event E, okay? That is there. So this is for part A. Yeah, right. My part B. When 2 dice are rolled, okay, here what is my sample space? How many outcomes I have for my sample space? When you roll 2 dice, remember, when you roll 2 dice, here 6 outcomes, there are 6 outcomes in total, 6 times 6, which is 36 outcomes, right? One of those 36 is 1, 1, 1, 2, and so on, right? The last one is 6, 6. So if you count this, you should have 36. Okay? Now among those 36, we are looking for the particular event E. What is my event here E? When 2 dice are rolled, we obtain the sum. The total should be 2 or 9, right? Remember, you need to add these two numbers to find the total. Find the total. Now I need to have 2 and 9, right? To get the total 2, what are the possible my outcomes among here? When you add two numbers, you should get 2. I have only one possible, which is 1, 1. To get the total 9, what are the possibilities?
4, 5.
4, 5, 5, 4. What else?
6, 3, 3, 6.
Very good. 3, 6, and 6, 3. Anything else? No. So these are the outcomes for number 9. This is the outcome for number 2. Combine all the outcomes and put into your event E. So my event E is 1, 1, 4, 5, 3, 6, 5, 4, and the 6, 3. Okay. Right. Oh, okay. Now this one is coming from 6.1 and 6.2. These two problems. Of course, these three. Okay. If a single card is drawn from a standard 52 cards deck, find the probability that we select those events. Remember, I am choosing only one card, right? Where's my sample space for this problem? My sample space is here. This is my sample space for that problem. You are choosing only one card. Now the question is finding the probability, right? Remember, we have the formula for the probability. Recall 6.1 and 6.2. The probability of any event E is given by the number of outcome of that event E over the number of outcomes in your sample space. Then we had the probability of any event's complement is given by 1 minus the probability of that event. Then we had one more formula, right? The probability of E or F, or means here union. The probability of two events union is given by the probability of event E plus the probability of event F. Then you have to subtract the overlap event for these two events, right? Right. After that, we had at last we had odds against an event. E is given by the fraction of P of E prime over P of E, and at last we had odds in favor of the event E is given by simply the reciprocals, flipping this fraction out, right? So these are the set of formulas we had last time. Okay. So now here, my event is this. This is my event E. You are choosing a single card. That card should be black with 9. Okay. So remember, the question is probability. So always we have to use the probability formula. So I'm using the formula P of E. My event E is now getting black with 9. So I'm using simply this formula. Okay. So remember, my event is getting black and 9. Go for your sample space and tell me how many such cards there are. Black with 9. This is black, right? First set of these two are black suits, clubs and spades. So you see 9 here and there. So there are two of them, right? 2 9s with black. Therefore, the number of possibilities for being a 9 with black is 2 over n of s. S is my sample space. Sample space is collection of all the cards. How many cards I have in total? There are 52 of them. Therefore, little n of s is 52. Okay. So if you want, you could simplify this fraction by dividing 2 and you will get 1 over 26. Leave your answer as it is. Don't try to, round up. You have to write the exact answer unless they ask you to round up. So I'm writing always in fraction form, okay? 1 over 26. Right. Remember, these all three are events, right? But we are finding the probability of these three events. Okay? Question all about the probabilities of these three. Now here, you have event, this is my event, but this event is now combined by 2 with OR. So suppose if your event E is face card, getting face card, and event F is getting clouds. Okay. Now I'm connecting with OR means union. That means simply they are asking us to find the probability of this event. Okay. My formula says that probability of E union F is here, right? You look at the formula, PE plus PF minus. So that's my formula. So this is the formula I'm using. This one, okay? Use that formula and write down. So my event E is getting face card. So the probability of event E is getting face card, right? plus I'm using this formula P of F. F is even getting clubs. Then you have to subtract the overlap, which is face and club, right? Let's find the probability of these all three one by one. Let's find out. Okay, let's find the probability of getting face card. How many face cards there in card pack? Go back and check. This is face cards, right? There are 12 of them. So getting face card. Remember, these all three are probabilities. You have to use this probability formula 3 times, right? So you have to treat these all three as a separate problems and find one by one. So the first one is finding the probability of choosing a face card. So I'm using this formula. So my event is now choosing face card. So how many face cards there in your card pack? There are 12 of them. Out of NS is now 52 always. Plus the probability of choosing clubs. Go back and check how many clubs there. This is my clubs cards. There are 13 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 clubs. So the number of ways you could choose clubs is 13, but out of 52. Okay, this is the confusing part. Student used to confuse. Remember, you are choosing only single card, right? Only one card. That card should satisfy these two conditions, right? You need to have a face card with club suits. Come to the club suits and check how many face cards there are under the club suits. I have 3 of them, right? These are the 3 face cards with the clubs. There are 3. So it should be 3 over 52. Okay? Now simplify this fraction, very easy because all the denominators are same. So simply, add the numerator directly. 13 minus 3 is 10, 10 plus 12 is 22 over 52, right? If you want, you could simplify this fraction. I think I could divide by 2, right? So it's going to be 11 over 26. Okay, so I'm leaving like that. Right? Okay, in similar way, again you have to use our formula for 2 events. Now my event is getting number 9 and my event F is getting S card. There's no space to do that problem. Let me do somewhere here. Right, so I'm just doing separately 8C here. Probability of choosing a 9 or S. So the probability of choosing 9 or S, formula says that this is my event G, this is my event F, or means union. Use the union formula. The probability of union F is a probability of E is getting number 9 plus the probability of getting A square. Then subtract the overlap 9 and A's, right? Okay, so what is the probability of choosing 9? Remember, you are choosing from your 52 cards, so how many 9s are there? 1, 2, 3, 4. There are 4 of them out of 52. Then the probability of ace cards, how many ace there are? 1, 2, 3, 4. Again, 4 over 52. Let's see who's telling. What is my last probability? One of you have to tell me. What is the probability of you are choosing one card? That card should be 9 and ace. Yes? What is the answer? Remember, you are choosing only one card. That card should be with number 9 and yes. Number 9 is here, right? Do you see any A mark on your number 9 card? You are choosing only one card at a time. So if suppose if you choose this card, do you see A here? A is separate card, right? There's no A in your number 9 card. So that means this event is impossible event, right? You can't have a number 9 with A's in one card. You are choosing only one card, right? So this event is empty event, impossible event. So the probability of impossible event is always 0. Therefore, this event is 0. The probability of that event is 0. Sorry. So then simplify this. 8 over 52. I believe you could divide by 4 here and you will get, divide by 4, you will get 2 over 13, right? Okay. What else? Number 9. Oh, there's a typo. You don't need. Just know these information. You are not given an answer, right? Then how do you circle? A coin is tossed 6 times. Find the probability of getting exactly 4 heads. Oh, now you see, now they are asking to round to 4 decimal places. A coin is tossed 6 times. Okay, so number 9. What is my sample space here? You are tossing a coin 6 times, right? So how many outcomes I have in my sample space? Now you have 6 tasks, right? So each task has a 2 outcome. Therefore, the number of ways this could happen is uh, 2 times, 2 times, 2 times, 2 times, 2 times, and 2. There are 6 2s because there are 6 tasks. So that should be 2 to the power 6 should be 64, right? Therefore, the number of ways you could make this, happen is 64 ways. My sample space. Okay, but if you look at the problem, find the probability of getting exactly 4 heads. Okay, so the probability of exactly 4 heads means so 4 edges, right? So this is my event E now. Formula says that the probability of E is N of E over N of S. Let's find out now first N of E. The number of outcomes in your event E. In another word, how many ways you could make this event. You are tossing 6 coins. Among all 6, I need to have 4 heads, right? So how many ways I could make? You are given 6. Out of 6, I need to know 4. So the number of ways you could make this happen is 62 ways. What is that? 6 C
15.
15. Okay. Yeah, 15. So I need a 15. So there are 15 possibilities to, make the event E happen. So that means N of E is 15. So what is N of S? Total number of outcomes in your sample space, which is 64. Therefore, 6 choose 4 is 15 over 64. So, so now take your calculator and simplify. Make it 4 decimal places. They're asking us to write in 4 decimal places. So 15 over 64.
2, 3, 4, 4.
Let's see.
0.2344. Yeah.
2344, right?
Yes.
Okay. Right. Last problem. Oh, this problem, the last one is of the team has a 0.45 probability of winning a game. So find the odds against them winning, right? So this is going to be my event E. They are talking about the winning, right? But we know the probability of winning is given here 0.45. If winning is 0.45, then what is my probability of E prime? E prime is the negation of winning, which is losing the game or maybe draw, right? So what is the probability of E prime then? Formula says that, look at here, the probability of E prime is 1 minus P of E, right? So we know now P of E is 0.45. If you subtract 0.45 from 1, you will get the remaining rest. That is my probability of E prime, which is 0.55. So I know now probability of E and the probability of E prime. Now go to the question. Question is finding the odds against E. So odds against E. Formula says that odds against E is given by PE prime over PE. Right? But I know the answer of PE prime. PE prime is 0.55 over PE is 0.45. So now simple this fraction. So it should be 55 over 45. So divide by 5 will give you 11 over how much? Is that 9? Okay.